3.3 universal gravitation. Okay, any two objects will exert force on each other. No two objects has mass. Newton's law of the universal gravitation. The force of gravitational attraction between any two objects is directly proportional to product of the masses of the object and inversely proportional to the square of distance between the objects. So force of gravity is proportional to the mass of the two objects and inversely proportional to the distance of the object. We multiply it by a constant g, gravitational constant, which is universal. It doesn't matter where in universal, g is a constant. Here, look at that. Earth's gravitational pull on a spacecraft some distance away, 1.2 in a magnitude. What will be the magnitude of the force of gravity on a second spacecraft with 1.5 times the mass? So M2 will be 1.5 times of M1. The distance of the Earth, the R2 is 0.45. Is 0.45 R1. So you already know the equation. F is G M1 M2. M1 is Earth, right? M2 here, and here is R2, power 2. And sub M2, I put 1.5 M1. (1.5 M1) divided by 0.45 R1 the power of 2 is 1.5 divided by 0.45 to the power of 2 is G M of E M1 divided by R1 power 2. Okay, that is the forces of the first spacecraft. So we just do that, multiply by this one. So I'm going to check that answer. Is 1.2 10 power 2 is the force felt by the first spacecraft. Instead of this, I can put 1.2 10 power 2, and then you multiply these two together to get the answer. See that here? Now you do question number 3, 4, and 5. This is page 141. So determine the magnitude of the force of attraction between two uniform metal balls of mass 4 kilogram used in woman's shot putting when the center are separated by 45 centimeters. So they all have the same mass. M1 and M2 is 4 kilogram. We have M1 R is 45 centimeters. You need to turn into the meter. And universal G is 6.67 10 power negative. If you do that, it's going to be very small. It's extremely small, so it's going to be almost 0. So here, question number 8, 9, 10, and 11 you can do. This is page 143.